Hey everyone, welcome back to Education is Life, your go-to channel for unlocking the wonders of learning. It is me, Joe Edgo, and today we're on Lesson 15 of the Arduino UNO R4 Ultimate Training Series, focusing on using I2C OLED display. In the previous lesson, you learned how to integrate an I2C LCD1602 display on your Arduino project as a convenient way of displaying a string of characters. You also learned how to connect a DHT11 sensor to read the temperature and humidity values and display them on a 16:2 LCD. In today's lesson, we'll implement a similar circuit, but instead of using a liquid crystal display, we'll be using an organic light-emitting diode or OLED display. Similarly, we'll read the temperature and humidity values from a DHT11 sensor and display the results on the screen. Finally, we'll discuss how to show graphics and animation on your OLED display. As always, before we start, a huge thanks to SunFounder for making this entire series possible. Throughout this series, we'll be using this amazing SunFounder Arduino UNO R4 Minima Ultimate Sensor Kit. This comprehensive kit provides everything you'll need to build exciting Internet of Things project. So, if you are still looking for a comprehensive kit, I highly recommend checking out this product. It's available on both the SunFounder website and Amazon. Links are in the description below. So now, let's begin. For this session, you need the following materials: an SSD1306 I2C OLED display, a DHT11 or DHT22 sensor module, a breadboard, some connecting wires, and your Arduino UNO R4 Minima. Here's how to connect everything. This is the same circuit connection from the previous lesson. The data output of the DHT11 sensor module is connected to pin 2 of the Arduino. Of course, we'll use the same 5V power supply of the Arduino UNO board to power this module. For the OLED display, the one included in the SunFounder kit is an SSD1306 I2C OLED display. This OLED display is made up of two key components: an OLED panel. This thin panel comprises tiny pixels, each containing organic materials that emit light when an electric current passes through, and a driver chip mounted on the back that controls the pixels using an I2C or Inter-Integrated Circuit Communication Protocol. This chip interprets signals from Arduino and translates them into commands for the OLED panel to display. Now, this OLED display that I'm using is a 0.96-inch screen, 128 by 64 pixels, monocolor display. However, if you have a different screen size, such as the 1.5 or the 2.5-inch versions, the connections to the Arduino are the same. This model has only 4 pins. However, please note that there are models that come with an extra reset pin. There are also models that communicate using SPI communication protocol instead of I2C. Now, since this SSD1306 is an I2C device, it will communicate with your Arduino using only 2 wires: the SDA or serial data and the SCL or serial clock. Connecting your SSD1306 I2C OLED display to your Arduino is super easy. Simply connect the ground and the VCC pins of the OLED to the ground and 5V pins of your Arduino respectively. Then, connect the SDA and SCL pins of your OLED display to the SDA and SCL pins of your Arduino. Please note that pins A4 and A5 can also be used since they are both connected to the same I2C bus marked with the pins SDA and SCL. Unlike traditional LCDs, OLEDs are self-illuminating. This means each pixel generates its own light in response to electric current. In effect, OLEDs don't require backlight, which result in a very nice contrast and brightness. Since each pixel controls its own light source, OLEDs can achieve true black levels. Now, because only lit panels consume power, OLEDs have lower power consumptions, making them ideal for battery-powered projects like smartwatches and wearables. In addition, they are smaller in size and light in weight than liquid crystal displays. To begin with our code, we need to install the necessary libraries to communicate with the SSD1306 I2C OLED display. First, open the Library Manager and look for the SSD1306 library by Adafruit. This is the library for monochrome OLEDs based on SSD1306 drivers. Now, click Install all the dependencies. This should install the required Adafruit GFX library as well, which is the core graphics library for our OLED display. So we can draw points, lines, circles, images, etc. In our sketch, let's include the Adafruit GFX and the Adafruit SSD1306 libraries. Then let's define 4 macros: the screen width of 128 pixels, the screen height of 64 pixels, the screen I2C address, which is 3C hexadecimal, or it may be 3D. Please double check your specifics OLED's documentation for its address. And finally, the OLED reset pin, which is -1 if it is sharing with the Arduino reset pin. Now, we need to create an instance of this Adafruit SSD1306. We'll call it screen and pass in 4 arguments: the screen width, the screen height, a reference to the wire object from the wire library, and the OLED reset pin. In the setup function, we initialize this using the begin method. Here, we pass 2 arguments: the constant SSD1306 switch up VCC, which defines the display voltage from 3.3 volts, and then the screen I2C address. Now, before displaying anything on the screen, it is best to call first the clear display method to clear any previous displays on the screen. So, to display text, we need to set the text size. 1 is the smallest. Then, set the text color to white. For this monocolor display, white means pixels will be on and black means pixels will be off. Then, we use the set cursor method to position the cursor where we want to draw or turn the pixels on. For example, if we want to draw or print something on the top left corner of the screen, we set it at 0, 0, that's XY coordinate. Then we call the print method to print a string of characters, say temperature. Now, to actually display it on the screen, we have to call the display method. Here, since we have 128 by 64 pixels, we have a total of 8,192 pixels for this entire screen to play with. However, please bear in mind that one character will not just occupy 1 pixel. Depending on the font type, style, size, and the character to be displayed, the number of pixels occupied may vary. Let's upload this program first for you to see what I meant. As you can see, the word temperature followed by a colon is displayed on the top left corner of the screen. Now, based on how it appears on the screen, even though this is only 11 characters long, it almost consumes about 70 pixels in width and about 8 pixels in height. Now, let's try printing another text below the temperature just to verify, but we'll display it somewhere in the middle. So, if the screen height is 64 pixels, let's display it at location 035. And let's print humidity. Again, let's upload the code and see how it looks. And it looks good. We still have enough space for us to display the actual temperature and humidity readings on these empty spaces. So let's try doing that. First, we call the DHT library, then define DHT pin at pin 2, and the DHT type, DHT11. Then, let's create an instance of this DHT class. And finally, we call the begin function. In the main loop, let's have a short delay of 2 seconds before reading the temperature and humidity. Now, let's move the code that prints the temperature and humidity inside this main loop. Similarly, let's check if either the humidity or the temperature reading is not a number. If so, we clear the display and print a message failed to read from DHT sensor. Now, make sure not to forget to call the display method here, otherwise you will not see this error message printed on the screen. And return to the main program. However, if we have a successful reading, then let's print the result. Now, to print the temperature readings, just below the word temperature, I'll position the cursor to 012 location, and then let's change the text size to 2. This is twice the size of the previous text. And then print the actual value stored in this t variable. Now, to display the degree symbol, the closest character used in the default font that looks like a degree symbol is character 247. So let's print this one as well. Finally, let's print the capital letter C. So for the humidity, let's do the same. I'll position the cursor to 047 location, just below the word humidity, and then print the actual value stored in the H variable. And finally, print the percent symbol. So let's upload this code to see if it works. And as you can see, it fits perfectly. We have a nice interface for our temperature and humidity monitor. If you are not completely satisfied on how a character or a symbol is rendered on the screen, you can always draw instead of simply printing text. For example, if you feel that this degree symbol is too large or too bold, we can replace it with a circle. To do that is very simple. I'll comment out this code and replace it with the draw circle method. The first two arguments represent the x and y coordinates. So, by estimating its location, I guess it's about half the width of 128 pixels. I'll add a few pixels just to be sure, say 66 pixels from the left. And then the y-coordinate is 12 pixels down. Then the third argument is the radius. Say we want 3 pixels, so that's 6 pixels in diameter. And finally, the color, which is white. Now, let's put a space before the letter C because we're expecting that this empty space here is where the circle will be drawn. Now, let's upload the code to see if it works. And it prints exactly where we want it to appear. Great! Now, aside from drawing circles, you can see that there are plenty of other methods you can experiment with, like draw line, draw rectangle, draw triangle, and basically, you can draw anything here. However, there is a method that we can easily use to draw images and even show animation on screen. The draw bitmap method. Here, we need to pass 6 arguments. The first two are the x and y coordinates, followed by a bitmap. Here, we need to pass in an array of characters or bytes that form the image, then the width and the height of the image, and finally the color. Now, say we want to display some sort of glyph or icon adjacent to this temperature reading, somewhere in this upper right corner of the screen. Probably it will fit a 32 by 32 image. So we'll place it in the location 96, 0. Now, for the bitmap, we need to create a constant array of unsigned characters. Constant because we will not be changing the values inside this array in our program. Unsigned character because we want to store numbers only ranging from 0 to 255, not including the negative numbers. For that, we can also use either the byte type or the 8-bit unsigned integer type. So we'll call this variable temp icon, followed by a pair of square brackets to denote an array. Now, by default, the data in this array will be copied to the static RAM similar to how other variables are stored when the program starts. However, to keep the constant data in flash memory only, this is where the program resides, we need to use this progmem keyword. It tells the compiler to keep this information in flash memory only. And then finally, we specify the array values here that represent the image we want to draw. We can do it manually, like plotting ones and zeros depending on what specific pixels we want to turn on or off to draw an image. However, this is time-consuming and very tedious. With this, I'll show you one simple way of doing it. First, get any image you want. Let's open our browser and search for the temperature symbol, PNG. Now let's choose one. Say, I want this temperature, free weather icon. So I'll right-click and save image as temperature.png. Now, open another tab and go to this web page. I've included the link in the description below. So this web page is one of the many online tools available that allow us to change images into byte arrays for use with monochrome displays such as OLEDs on your Arduino or Raspberry Pi. This is easy to use. First, select an image. Here, you'll see the image being previewed right away. Then, change the canvas size. So we only wanted a small image of 32 by 32 pixels. Now, as you can see in the preview, the image disappears. So what we have to do is to change the scaling and choose scale to fit, keeping proportions. And there you have it. Now, notice here that the background color is set to white. It means that when this image is rendered on your monocolor OLED display, you will see a white square, and those are the pixels that are on, with a black temperature image drawn in the middle. If this is not what we want, we can simply select black and check the invert image colors. On the code output format, it is set to Arduino code by default, and the last thing to do here is to generate the code. And as you can see, this is what we need. All we have to do is to copy these values and paste them into our array. Now going back to the draw bitmap method, we simply pass this temp icon array, and the dimension is 32 by 32, and the color is white. And that's it. Now let's upload the code and see if we can display the image correctly. And as you can see, we were able to display graphics on our OLED display. Displaying animation is also simple. We can display images in sequence at a certain interval or frame rate, one after the other, to make our images move. To do this, I'll show you another great online tool that we can use to include animation in our code easily. Go to animator.walkme.com. And there are dozens of great animated icons here used for Arduino. Let's go to the weather tab since we're creating a portable weather station. And then let's select this one. Now you can see here the preview of how it looks on your OLED display. You can change the size, say 48 pixels, and the preview is updated right away. Now, click the Get Code button, and this gives us an Arduino sketch to run this animation. This code is quite long, but the majority of it consists of data for byte array or image. This is the first image. This is the second image, the third, down to the 28th image. All are arranged in a two-dimensional array. We'll talk more about multi-dimensional arrays in future videos. However, the idea here is that each image is going to be displayed one by one, but will last for only a certain period of time. So, if we have 28 images in sequence stored in this array, basically we have 28 frames to display. And this code uses a constant delay of 42 milliseconds per frame. After this array declaration, you can see here that the code is very short. First, we have this frame variable that starts with 0, and this is very important. Every time the loop executes, it clears the display before drawing an image. However, the image being drawn is different from the previous image because of this frame variable that counts from 0 to 27, and this is done through this code. When the frame count reaches 27 plus 1, which is 28, and then divided by the frame count, which is 28 as well, the remainder is 0. It simply means that this frame gets displayed first. This is frame 0, followed by this image frame after one loop, and this is frame 1, then followed by this image after another loop, which is frame 2, until it reaches the last image, which is frame 27, and then the cycle repeats. And as you can see, the rest of the code is very similar to what we have created so far. So, let's copy this code, and then I'll create a new sketch and paste it here. Now, there's one thing we need to change in this code. The screen I2C address. Our OLED has an address of 3C instead of 3D. So now, let's upload this code and see if it works. And it works great. We have a very nice animation that loops continuously. For your challenge activity, try to improve our previous project by adding another image adjacent to the humidity readings. Look for any free images online that you like and repeat the similar process that we did to convert the image into a CPP Arduino code. In addition, include a simple animation when the program starts, before displaying the humidity and temperature readings. Again, thank you so much for joining me in this lesson on I2C OLED Display. To keep this educational channel rolling, your support is very important. Please know that your likes and subscriptions fuel this channel. And by hitting that like button and subscribing, let me know you're enjoying this content. So, if you know someone who might find this helpful, don't hesitate to share it with them. The more viewers we have, the more in-depth content I can create for you in the future. Again, keep learning, keep experimenting, and always remember, education is life. See you in our next lesson. Happy coding!